Welcome to Instrologic channel. In this video, we will learn what is electromagnetic flowmeter and its working principle. So, let us start the video. Electromagnetic flowmeters are used to measure the flow rate of conductive liquids. It works based on Faraday's law of electromagnetic induction. It commonly used in water, wastewater, and chemical industries. It has no moving parts, and it is ideal for dirty or corrosive fluids. Let's understand the Faraday's law of electromagnetic induction and how it applies to an electromagnetic flowmeter. What is Faraday's law? Faraday's law says that when a conductor moves through a magnetic field, an EMF or voltage is induced across the conductor. In simple words, movement in a magnetic field creates electricity. In an electromagnetic flowmeter, the fluid inside the pipe acts as the conductor. Magnetic coils around the pipe create a magnetic field across the flow tube. When the fluid flows through this magnetic field, a voltage is generated. Electrodes placed inside the pipe sense this voltage. The amount of voltage depends on how fast the fluid is moving. The flow transmitter then converts this voltage into a flow rate reading. Faraday's law helps us measure flow without any moving parts. It's accurate and works well for conductive liquids. The flow tube is lined with a non-conductive material. Two magnetic coils create a uniform magnetic field. As conductive fluid flows through the field, voltage is induced. Electrodes placed opposite each other measure this voltage. Flow transmitter converts voltage signal to flow rate. Flow rate is directly proportional to induced voltage. Let's look at the main parts of an electromagnetic flowmeter and understand what each part does. At the top, we have the transmitter. This is the brain of the flowmeter. It takes the signal from the electrodes and converts it into a flow reading. The display shows the flow rate and other parameters so we can monitor the process. The cable gland is where the electrical cables enter the transmitter. It keeps the connection safe and prevents dust or water from entering. Next, the big blue body is the coil housing. Inside this housing, there are magnetic coils that create a magnetic field across the pipe. This is important because Faraday's law works when the fluid moves through this magnetic field. The earthing ring ensures proper grounding. It helps to avoid electrical noise and keeps the measurement accurate. Inside the pipe, there is a liner, usually made of rubber or PTFE. This liner protects the metal body from corrosion and makes sure the fluid does not short-circuit the electrodes. Finally, the flanges on both ends are used to connect the flowmeter to the pipeline securely. So, the transmitter processes the signal. The coils create the magnetic field, the electrodes sense the voltage, and the liner and earthing ring ensure safe and accurate operation. This is how an electromagnetic flowmeter works. These are the advantages of the electromagnetic flowmeter. These are the limitations of the electromagnetic flowmeter. When we choose an electromagnetic flowmeter for any application, we need to check several important factors. Let's go through them one by one. Step 1. Fluid conductivity. The fluid must be conductive for the electromagnetic flowmeter to work. The minimum conductivity should be around 5 microsiemens per centimeter. If the fluid is non-conductive, this type of meter will not work. Step 2. Pipe size and flow range. Next, we need to know the pipe size and the expected flow range. The meter should match the pipeline size and handle the required flow rate. Step 3. Process pressure and temperature. Check the pressure and temperature of the process. The meter should be rated to withstand these conditions safely. Step 4. Liner material. The inside of the meter has a liner. It should be compatible with the fluid. Common materials are PTFE or rubber. This prevents corrosion and ensures long life. Step 5. Electrode material. The electrodes that sense voltage must also be compatible with the fluid. Materials like stainless steel, hastelloy, or platinum are commonly used. Step 6. Installation location. Choose a location that avoids air bubbles and vibration, because these can affect accuracy. Step 7. Signal output. Decide what type of signal you need for your control system. Options include 4 to 20 mA pulse or Modbus communication. Step 8. Power supply. Finally, check the power supply. The meter can work on AC or DC, so make sure it matches your system. So before selecting an electromagnetic flow meter, always check fluid conductivity, pipe size, pressure, temperature, liner and electrode materials, installation conditions, signal output, and power supply. Now let's understand the installation guidelines for EMFM. Correct installation is very important for accurate measurement with an electromagnetic flow meter. Let's go through the key guidelines. First, the flow meter must be installed in a fully filled pipe. If the pipe is not full, the reading will be wrong. Second, provide a straight section of pipe before and after the meter. The rule is 5 times the pipe diameter upstream and 3 times downstream. This helps to avoid turbulence and gives accurate readings. Third, do not install the meter near valves, elbows, or pumps. These create disturbances in the flow and affect accuracy. Fourth, ensure proper grounding and cable shielding. This prevents electrical noise from interfering with the signal. Fifth, mount the meter so that the electrodes are horizontal. This gives the best performance and avoids air bubbles collecting on the electrodes. Sixth, never install the meter at a high point where the pipe may run empty or in a downward bend where air can trap. These conditions will cause incorrect readings. To summarize, keep the pipe full, provide straight runs, avoid valves and bends, ensure grounding and mount electrodes horizontally. Following these guidelines ensures accurate and reliable flow measurement. Let's summarize this video. Electromagnetic flow meter is a reliable, accurate, and maintenance-free device for conductive liquid flow measurement. Based on Faraday's law, it converts induced voltage into flow rate using smart transmitters. No moving parts. Linear response, ideal for industrial automation and process control applications.
Thank you for watching this video. Do subscribe and like for more informative videos.